This is a proof of concept for a water level detector circuit. So the components, we have BJTs here with some LEDs, some switches, then we have a comparator, a 555 timer, and a MOSFET. And this is our motor over here. We're gonna act as if that's the water pump. So the way this works is these switches represent mechanical float switches, which when the water level rises, they float, and a magnetic ball will roll down into a little compartment, which will complete the circuit, allowing current to flow. So there's two configurations for these switches, always on and always off. So right now they're always off. So the idea is that whenever the water gets to the first float switch, it floats up and it drops that magnetic ball, completing the circuit, which allows this first LED to turn on, indicating we're at about a third of the way, or a quarter. Then we get to the second float switch, and that one completes the circuit. So it turns on this yellow LED. And then we have the red one, which they can all be on. If I press them all, I'm not gonna do that. The idea here is that this pump is always on, which this is the trouble I'm having right now. I'll get to that here in a second. But the pump is supposed to be always on the moment you hit the switch. It's not controlled by these two, but the moment you hit here, this upper level of the water, it'll turn the pump off to stop putting water in it. The only reason it's not really controlling very well is the comparator's a little messed up. It only wants to output low voltage, and it will not go high at all. I tried troubleshooting this and even tried a op amp in a comparator configuration, and that didn't help either. But the idea would be that whenever this red LED switch comes on, it sends that high voltage to the comparator, and then the comparator sends a low voltage to the reset pin on the timer. And the timer overrides the turn on switch for the timer, so it will turn off the pump regardless of what's going on in the rest of the circuit.